But the idea is we want to reuse those queries as much as we can. Now, let's assume that it's not there. It's not in the cache. You can't find it. So what SQL Server will do is it will create a query tree. And it will then hand that off to kind of the crown jewels of any of the relational databases, to the query optimizer. And SQL Server goes through a multi-step process to optimize that query and turn it into basically actionable instructions. So let me tell you a little bit about that. The first thing it takes a look at is phase 0, kind of pre-optimization. And this will produce what SQL Server calls a trivial plan. And there's actually a switch, a trace flag switch you can turn on that will tell SQL Server to keep trivial plans. But by default, it just throws them away as soon as it uses them. A trivial plan might be something like get sysdate. Right? I mean, I don't even have a table. I just need to get a value that I know all the time. There are other really trivial plans too. The next thing it does is it starts to look for simple operations that it can perform. Very, very simple operations, like a nested loop, join. So I need to pull data from two tables together. And so that's called a transactional plan. And with a transactional plan, there are some rules. Like if SQL Server checks to see how many tables are involved in the query, if it has more than 3, then I skip it. I can't even develop a transactional plan. I have to go to the next stage, which is even more elaborate. That's when it produces what's called a let's see. Sorry?
Full optimization.
Didn't catch
Full
it.
optimization.
Yeah, a full plan. Thank you. And so it begins to apply what are called heuristics. Not a commonly used word these days, but the query optimizer has this enormous tree of choices it can make on how to develop a really good plan, execution plan for this query. And it starts to look for indicators in that query about which path it will choose. And so one of the first things it looks at is it just a value? Does it have a from clause? Does it have a where clause? Okay, yes it does. Now does it involve more than one table? Does it involve more than 2 tables? Does it have a not? Believe it or not, the not operator causes it to choose all kinds of other paths. Why would that be, by the way?
You can't take advantage of the indexes as well.
It can't take advantage of the indexes as well. That's possibly true. Another thing about relational databases is that they're really well designed to find values, but they're not well designed to find not the presence of a value. So if you're designed well to find a value, how do you find if you don't have that value?
Find every single value.
You have to find every value first and then exclude everything that you think should be there that's not, right? So now that means we have to go down this whole other route of the execution plan. And then finally, that last level of optimization, which is phase 2, is the full plan, and that's when SQL Server starts to do things like parallelism. It's like, wow, this is a big, serious operation. I can actually even split this up across all 16 CPUs that I have given to me. Now I have to break this into multiple parts. So as you can see, that's complex stuff, and SQL Server might have to send Sheldon to every floor of the building and then all the way back down to get a good execution plan for this. So it's hard work, and it wants to reduce the amount of hard work it does as much as it can. Now, from this point, it actually produces something called a query plan fingerprint, or sometimes called a hash. So it does a hashing algorithm on it. It's 1/26th the size of the actual human-written, readable with the naked eye sort of thing. You can't really read it now. If you were looking at the machine code as it was processing through, you couldn't read it at this point. And hands it over to the query executor. The query executor then basically says, where am I going to, so far everything I've done has been kind of speculative. I haven't actually executed anything. Where am I going to actually get this data from now? So it hands off to the storage engine. Now, if you haven't added this resource to your list of resources to read, you need to add Paul Randall's blog, sqlskills.com/blog/Paul. Paul is with a company called SQL Skills, one of the top consultancies for SQL Server, and he holds the patent for DBCC check table. He was the head of this team for a long, long time. And he also has a gift for writing. So his writing is extremely detailed and very, very clear. So if you want to become a master of SQL Server, read Paul's stuff. And in fact, everyone who writes at SQL Skills. So what happens is, SQL Server then interrogates the access methods part. You know, Sheldon has to get on his bike and go over a bridge. And the access methods is the part of, if you've ever looked at an execution plan of a SQL statement, you'll see that there are logical operators and physical operators, and they're not quite the same thing. So it might say inner join, but then it says, left, well, it might say outer join is the logical operation, and then it says a left semi-outer join, or left semi-anti-outer join. So what does that mean? So one of those is the logical, the other one is the physical, the way in which it will actually go out and get that data. So SQL Server says, based on what I know about the indexes, based on what I know about the distribution of data, the cardinality of that data in the tables, maybe if there's multiple files and file groups, this is how I plan to actually go and get that data. That's what happens right here. So SQL Server then says, okay, where am I going to get this data? I mean, where does it live? So now I've figured out how I'm going to get there. Now I have to go out and get that. And so it hands that request over to the buffer manager. And just like before, with the command parser, the buffer manager, its job is to save us as much work as it can. And the rule of thumb is about 16 to 1, perhaps 30 to 1, in terms of the amount of time it takes to process something I/O bound versus memory bound. We'd rather do it in 1/30th the time and get it from memory than we would from the hard disk subsystem. So we're going to check to see, the buffer manager is going to check to see if that data already is loaded into the data cache, right? Why would I go out to disk, which is really slow, when somebody else might have queried the exact same thing and had that loaded up in the RAM, right? Now, the buffer manager is going to look for that data, and if it doesn't find it, then we have to go here. Out to the...
May I have your attention, please? May I have your attention, please? This is your fire safety director.
I know that I have been guilty, and I've heard other experts occasionally say something like, well, that's when we have to go directly to disk. We don't want to do that. And that's actually a misstatement. SQL Server never does anything directly to disk. What it does is it will come out here and read all the data that you requested from disk and put it into the cache. And then it will act upon that data, right? So that takes some time. And once it's loaded in to cache, we can then answer Sheldon's question. Right? So it takes all these different steps. Have to go through all these different processes throughout the system to finally get that 14 rows returned message at the end of, executing that select statement. Now, let me dive in a little bit deeper onto a few of the things that happen here. Okay, just to go back for a second, when Sheldon makes his initial connection right here at this point, SQL Server invokes a part of the system called the SQL OS, the SQL operating system. And it used to be called the scheduler, the UMS, the user management, or I believe that's it, the user management scheduler. So let's change our analogies a little bit. Every time we connect to SQL Server, it's as if we're going to go through a drive-through, and when we get up to the counter, we make our order. And most of the time, that's going to go really well. I would like 40 rows of data from this table, please. I'd like chicken nuggets and french fries. And sometimes it does not go so well. Something bad happens. And so this is good and bad for us in a couple ways. The thing that's cool about this is that we know that SQL Server is basically going to create one scheduler, typically, per CPU on the system. And then users get assigned to those as threads, as SPIDs, system process IDs. So if you've used Activity Monitor or SPWho or SPWho2, you'll see all these SPIDs. And those that are 50 and below, I think it's 52 and below now, are system processes. Things like the lazy writer and checkpoint processes, ghost cleanup. Users will be greater than 50. What is really, really good about this is that it gives us some awesome troubleshooting information. And I want to explain that just kind of quickly. If we're able to get our Happy Meal and Coke quickly, if we're able to get that activity on the CPU, you'll see your SPID is running. Everybody else who's waiting for an opportunity to get onto the SPID will be a runnable process. They're not yet running, they're runnable. Now, sometimes we will do some activity and we won't be able to get what we want. We've got some Amish people in front of us and they're in a horse-drawn carriage. Or in my case, I have 7 kids, so maybe they have run out of every French fry in the place. So they'll say, step out of the line and we'll bring that to you in just a minute. Same thing happens inside a SQL Server. So what SQL Server will say to you is step out of the line. Step out of the runnable queue or the running queue and go to the suspended queue. You have to wait. This is awesome news for us because if you're ever trying to troubleshoot your SQL Server, everything that a person or a process has to wait on to complete is logged and tracked by wait statistics. And those wait statistics are categorized in a very troubleshoot-friendly way. So you can see, am I waiting for I/O all the time? Am I waiting for memory all the time? Am I waiting for compute resources all the time? Is my network slow? What is causing the problem? And that's in a wait stat called DM. Wait stats.
DMO is the waiting state.
DMOS wait stats. So those begin to accumulate. Basically, there's 2 big categories. One's called the signal wait. That's these guys down here who said, I've got everything I need, SQL Server. I'm signaling. I'm ready. Put me on a CPU. Put me in, coach. I'm ready to play. They just need that. They just need the CPU. That's a signal wait. Then there's the resource wait. That's the other big category. I don't have the locks I need to execute this transaction. I don't have enough CPU. I don't have enough speed for my I/O subsystem to complete in time. So as these schedulers assign the different users to threads, process their work, you can find out where your SQL Server is waiting any given time. What is making it slow? It's very useful. Now the other thing I want to do a call out on is on the caches. It's a very important question. I told you how if it doesn't find that data in cache, it'll come out to disk and load it up into cache. But how long will that data stay in cache once Sheldon has pulled it in?
Depends on pressure. If you don't have pressure.
It depends, right? The true answer to every technology question is, it depends. Thank you. The simplest answer is what's called an LRU algorithm. It's actually an LRU-K algorithm, least recently used. Very good. What happens is there's a process called the lazy writer in SQL Server. I used to think of this movie with Peter Fonda and Jack Nicholson with big Harleys and lots of marijuana. That's a different kind of, it's lazy writer. No, easy writer, I'm sorry. The lazy writer looks around approximately every minute or so. And so let me explain to you how it keeps up with the cache. Let's say that we are going to execute a new stored procedure or a new query, a new transaction called get order. And there's already stuff loaded into the cache. Okay? SQL Server creates 2 numbers based on everything that goes through that query optimizer. The first is the complexity value, and the second is the complexity counter. So when I was telling you about the query optimizer, SQL Server has this kind of built-in rule that whoever is issuing queries against the engine, the database engine, is an impatient, very obnoxious human being who demands their data now. So SQL Server doesn't try to produce the best plan, the best query plan. It tries to produce the optimal query plan. What's the difference between best and optimal?
In the certain time, in certain time to find the best plan.
That's right, time. So it uses a cost-based algorithm to figure out how difficult it will be to process this query. But SQL Server, by default, basically has about a half a second to figure out what is the best execution plan. Now there's a trace flag you can actually set to change this, but by default, SQL Server says, if I can't figure out something awesome in a half a second, I'll take whatever I got, whatever's good, whatever I came to first. So there are plenty of times when you might have, let's say, end of month processing, and boy, wouldn't it be great if we could have this run for like 3 minutes to figure out a really good, even better execution plan? SQL Server is not going to do that. So what it will do, though, is it uses that cost-based optimizer to calculate a value of how complex it is, and then a counter that's a shadow of that. Now, every minute or so, the lazy writer wakes up from the party he was at. He walks back into the room, takes a look around to see what has happened. Has anybody used these? Have I used it, right? If it hasn't been used since the last time that the lazy writer came through, the counter gets decremented by 1. Another minute passes, the lazy writer takes a look around. I'm looking to see if any of these drop to 0. Right? So that really complex query, the get order query, it was hard. Took a lot of work for us. We had to go up all 72 floors of that building. We don't want to do that again if we don't have to. So we're going to give that one a lot of time in the cache. But this SP_4, I mean, it took us, 2 nanoseconds to build that plan. So we don't care if we have to redo it. It's easy. So the lazy writer looks around again, and have any of these changed? Have any of these decremented since I was last up here? Some of these will hit 0 and kind of less than 0. What do you think SQL Server will do to those that go from 0 to now decremented 1 more than 0? What it would seem like it would do is that it's going to clear them right out of the cache.
No, I just leave it there until they need the cache for something else.
What SQL Server actually does, though, is it ghosts that particular execution plan. So that execution plan is allowed to stay in cache as long as there's not memory pressure. I mean, if there's no pressure, if we got half a terabyte of RAM and we don't have a lot of people asking for that space, we'll go ahead and leave it there. But the minute that somebody needs the space of a ghosted execution plan is consuming, we'll delete it at that point.
How does the lazy writer know if it's been used?
How does the lazy writer know if it's been used? Basically, there's a now on the data side it's a little different, but basically there's little headers in the memory space that it's allocated that indicates whether it's been used or not, whether a data page has been changed or not, whether a record has been ghosted or not. So there's little header, 1 bit. All it has to do is read 1 bit as it looks through the different pages that are in the cache. And so that speeds it up, that whole process. It doesn't actually have to read every page. It just looks at this 1-bit flag on each of these different segments of memory, so it can go through it very, very quickly.
So it has to turn that bit off every time it runs?
Does it have to turn off that bit every time it runs? No.
Well, something has to happen so it knows it's different.
It only has to change those that are. It only has to change those that are being ghosted. And then if you'll look in the list of SPIDs, you'll see that there is a SPID called the ghost cleanup process that actually does the changing of those flags. Yes?
Yeah, 2 questions. One, the checkpoint affect these counters?
Okay, great question. So does the checkpoint affect this? Let me answer that. Oh, by the way, I'll answer that in just a moment. Okay.
And the second question, once you have the count becomes 0, and you have many pages count equals 0, when the data writer decide to clean up these things, what's the priority to, or just running again?
What is the priority? I actually don't know that off the top of my head. I don't know which one it starts with. I'll have to look that up for you. Yeah, good question. Now, if somebody has executed any of these, their number gets reset. The idea is the more complex it is, the longer we want it to live in memory. Okay? Now, they say that there's good questions and great questions in presentations. A good question is one that addresses something you're talking about right now. A great one addresses something you're just about to talk about. So that was a great question, because the great question is, what happens for data? Right? It's a little different for data, and what happens with data, I'm going to actually fast forward past this too. And this is the state of the art, and this is the very best of my PowerPoint animation skills too, by the way. So I hope you're enjoying it. What about the buffer cache? How does it choose and prioritize and do things like that? The short answer is it's basically the same. The long answer is if I was to fully explain it, it would take the rest of the day. Because SQL Server has so many levels of nuance, like there's a whole branch of the heuristics for how long it stays in memory according to how big the table is. If it's coming from from the whole table, if it's coming from an index column that's clustered, a non-index column, an included column, is the table bigger than 20 gigabytes? Then do this. If it's between 19.9 gigabytes and 10 gigabytes, then do that. If it's between 9.9 gigabytes and 5 gigabytes, so there's all kinds of degrees of nuance and context on the buffer cache. Basically the same thing. Basically LRU aging algorithm, but a lot of very, very granular details as to how that's handled. I have like 16 pages of notes that I thought I'd write up someday as this huge blog post, but it's going to take a lot of work to make that happen. All right, sorry, we're running short on time. We got to hustle on through. So, writing operations now. We talked about reads. What about writes? We tend to think of writes as inserts, updates, and deletes. Those are all what we call the DML statements, the data modification language of SQL. There's also a merge statement. That's a newer one they added at the last SQL 3 release in SQL 2003. But don't forget that grant operations and revoke operations also write. Create, drop, alter, they also write. They just write to metadata rather than user data, right? So they will do similar sorts of things here. So let's say we're going to change some data. He booked a ticket somewhere on Travelocity. Now he wants to change the date that he initially set. Once again, TDS packages that get wrapped up into the SQL Server network interface that gets passed over to SQL Server as a language event. If it's SEE LCT, it says I can't interpret this as a language event, so I'll throw it out. But if I accept it, the command parser will then say, all right, let's take a look. Does this exist in here? Now, because everything that's stored in the data cache is a hash, and about 126 the size of the human readable code, it's a very fast scan to take a look in the plain cache for that data, to see if something like this has been executed before. If we can find it, we'll use that, and we won't do any of these things on this side. If we can't find it, once again, we have to build the query tree, and from the query tree, we have to go to the optimizer and build the execution plan, the query plan. How many of us have worked mostly with SQL statements? That's the majority of what we work with. It's okay, don't feel bad. All right. How many of us also write inserts and updates and deletes and things? Okay. And a lot of people didn't raise your hands at all, so.
Don't do anything.
They're like, I'm waiting for the knitting classes to start. If you've ever tuned, you remember tuning your first delete statement? Hopefully you followed this pattern. You write a select statement first to make sure you get just the right data. Does that sound familiar? I had one guy say, no, I just do rollback.
Do the backup before we do it.
Yeah, do a backup first, and if it didn't work right, if you go to the next, a lot of times most of us will write code just till it works, right? Does what it needs to, but we don't tune it. But if you ever go to the step of tuning code and you look at execution plans, I remember I was really kind of just surprised by how different the execution plan was between the select statement that affected the 3 records I wanted it to, and the delete statement, or the update statement that affected the same 3 records. Why would that be?
Logs.
Logs?
Yes.
All right. What other reasons?
You might have to, if it's an index, you might have to rearrange things.
If it's an index, it might have to rearrange things. Okay.
Dependencies.
The biggest thing is dependencies and constraints. So if I'm deleting 3 records from a header table, and there's a foreign key relationship to a detail table, what do I have to do? I have to check it, right? And what is a check? It's a select, right? So now I have to include all of the operations, the execution plan of that select statement. And what if I have a unique index on that table? How do I ensure something is unique? I have to read the table to make sure that all the other values, that I'm not putting in a duplicate value, right? And, what if I have some kind of check constraint that says that the values have to be, between this range? I got to do, yeah. And SQL Server will also include in any triggers as part of that execution plan. So if you have, delete triggers or update triggers or any of that sort of stuff, that will, so I've got a, 5-10 line execution plan for a select statement, but then I write an update on it, and it's like four pages. I'm like, what have I done? It's like, don't worry, it's okay. Hopefully it's okay. Doesn't guarantee it's going to be good, just there is an explanation for that. Now, this is where things get really different. You remember the asset properties of transactions? This is where all that overhead kicks in. The access methods now has to invoke this big block here, the transaction manager. And it has 2 subordinate components that are very, very important. It sounds like when I'm really drunk and at a rock and roll concert, rock and roll, lock and log. No, rock and roll. Sorry. The lock and log manager, right? So it has to invoke the lock manager for transactions, processing. I have to make sure that I'm not, overriding somebody else. And most important thing of all, the thing that's going to take the most time out of probably all of this is making sure that it gets written to the transaction log. Again, it's a hash, so it's 126, what we would see with the naked eye, but it has to go here first. If it doesn't complete this operation, it won't do it at all. And so when you start up SQL Server when you restart it after cycling it, you'll see that it'll say, as it goes through each of the different databases, 4 records rolled forward, 3 records rolled back, 2 records rolled forward, 1 record rolled back. And it's reading that transaction log to get up to the current point in time to make sure that they're either all the way there or not there at all. And you'll also see sessions at pass, ones that you can stream, sometimes at the SQL Saturdays, about how to tune your transaction logs for maximum performance. Because if people have to wait for this to get done, nothing else can happen until those transactions get written. It's extremely important for good performance. Same time that that's going on, the lock manager makes sure that the user operations will work the way that you set, according to the isolation levels that you set. So the lazy writer is used for the plan side, and then to make sure that all of this gets made permanent. Once again, we're going to check to see if that data exists in cache. So if we have, we're going to read 4 gigabytes of data from a really huge table, we might have to load a lot of data from out here. But if it's, 5, 10, 20, 100 megabytes of data, it might already be in cache. And so if we can change it here without going here, we'll save ourselves a lot of time. What happens to one of those data pages over there after we've gotten it into the cache? What happens to it when we have made a change? Now, it's been written to the transaction log. It won't even try to write it to the data cache until it's in the transaction log. What happens to that, though? That data page
is dirty.
It is, you're right. It is a dirty page. Dirty. You're so dirty, you dirty page. Anybody ever been to like England and you flip open the newspaper and you hit about, what is it, page 6, and you're like, what the hell is this? That's a dirty page. I don't know why they chose this term, but dirty page simply means it's different in cache, in memory, than it is on the disk. So we have an 8K data page up there that's been changed, and again, there's a little bit right there in the header of the page that gets marked as there's a change on this page. That's why differential backups are so fast, because when SQL Server does a backup, it just looks to see which 8K data pages have had data changed, and then it just backs up those pages. It doesn't have to read it.
The extend bit
The extent bit?
the BCM page. Check the BCM page. The scan, right?
All right. So it does a scan. It finds that very quickly. Now, the part that makes sure that the disk or the I/O subsystem is in sync with what's in cache is the checkpoint process. The checkpoint process, again, runs about every minute or so, but it runs as often as you set the recovery interval setting in the data or the server settings. So if you use SP configure or the server properties, look for recovery interval. And if you want that number to be bigger, you want it to run every 5 minutes, you would change that to the number 5. Or you could leave it at 1, which is the default. So every minute, it's going to try to synchronize what's changed in cache and synchronize it out here at the disk. So people can continue to do all their work without it being up to date down here. One of the problems you'll run into is, and I noticed a lot of you raised your hands as developers, is that a lot of people will, by default, use the with read-only, right? Option hint, your query hint. So what does that mean for your processing? Dirty reads. It means you may be reading something in cache that hasn't been made permanent on disk. So I've heard a lot of developers say, hey, this is great because it's faster. I'm not going to put locks on certain kinds of things, and it makes my transactions go much faster, which is kind of true. It can make your transactions go faster, but is faster and wrong better? I encourage people not to use that unless they know exactly what they're doing, right? And you know exactly what the impact of that is. So once that has happened, once it's actually changed here and written to the transaction log, that's when Sheldon will get the confirmation that his transactions are complete. It won't be complete until the checkpoint runs. All right? Does that make sense? Okay.
What do you mean the one complete before the checkpoint run? They actually finish the commit.
Let's say, for example, he does a commit, right?
That's it.
It will be changed in the cache, but it may not be written out here.
But they're guaranteed transaction.
But the transaction is guaranteed to exist because of the transaction log. Does that compute? Sound okay? How are we doing for time? I think we're way out of time. The other thing that's kind of neat about this, and I haven't gone into a lot of detail about it, again, with a lot of concepts they're trying to get into a short period of time, is that with trace flags, you can modify the behavior of SQL Server to cheat in all sorts of ways. So I'm not encouraging anyone here to use trace flags. But what I am saying is if you have special needs and you call up Microsoft, sometimes they'll say, I want you to turn on this specific trace flag based on the problems you're having, and it will give you better performance. The question?
Can you also somewhat describe the general relationship to current RAID technology? I mean, the SAN technology.
Okay, so a question is about RAID and SAN technology. So, and while we're pausing, folks, if you would take a moment and fill in the evaluation card, because there's just a summary slide after this. The volunteer was supposed to have given those out. Sorry about that. He only left like 10 here, so. Thanks. So let me direct you in this way. If you go to kevinekline.com/slides, I have a whole presentation, including a recorded video, talking about I/O and disk storage systems. As far as SQL Server is concerned, it doesn't care what this is. It's just a file on a file system. It could be very fast. It could be very slow. It could be a SAN. It could be an SSD. It could be RAID level 5, RAID level 10. All kinds. So check in on that slide deck, because I go through all the different RAID levels and what they mean and that sort of thing. Yeah, good question. Did you have a question?
Yes, actually. What happens, let's say, when you have a checkpoint and at the middle of the checkpoint, like when the transaction not writing to the data file, what happens when, like suddenly, let's say we have a lightning, right? Like what's going on?
So what happens if SQL Server has a failure before a checkpoint can complete? Yes. That's why they call it recovery interval, because that's the maximum amount of time you can lose data during a recovery experience, right?
mean, what'll happen is, wait, when SQL Server starts up again, it's gonna replay all the transactions.
It's gonna replay all those transactions.
With those down.
Right.
And then anything that's not committed is just gonna roll back.
Anything that's not committed will have to roll back and be undone. So it's either completely done, or if lightning hits it before it can complete the checkpoint, it will have to undo all that. Yes, question?
What I'm not clear about, is it actually writing to the transaction log physically on disk?
Yes. It is physically writing to the disk, and it will not go to the next step, nor will it process any other transactions until the current transaction being written to the transaction log is completed. So if you have a slow transaction log, everyone will be slow. I've seen people spend $2 million on hardware, and they didn't tune the transaction log system, and they could scale to like 20 concurrent users when they're expecting 2,000, because they didn't plan for that one thing. Let me do this as we go forward. Let's wrap up.
Oh, I understand that.
Management consultants will tell you that the most high-performance teams in the world, the one that we should model ourselves after as IT pros, as business people, are actually race car pit crews, believe it or not. They're highly specialized. They do one thing really, really well. There's a person at NASCAR or Formula or whatever your favorite kind of racing is. They just have a giant gas tank on their shoulder, right? They run up, fill it up, and they run away. But nobody gets hired on that team unless they know mechanics inside and out. They have to know about the internal combustion engine. You can't be the gas guy and not know everything there is to know about the car you're working on. And I would suggest to you that as IT pros, it's the same kind of thing. We really need to know how our engine works, not just kind of casually, it's like, I think the gas tank is on that side. No, we really need to know how this works. Some of the top things that enable us to know those sort of stuff are the fundamentals, the context. So what does ACID stand? What does A stand for? This is a D. C? I? Isolated. And D? Durable. Thank you. Very good. How about the key components of the relational engine? There were 3 components.
Relational engine and
Query optimizer.
transaction manager,
Command parser.
access manager,
No, okay, up at the top. At the top box,
optimizer.
we have the optimizer, the parser, and the executor, right? Or executor. Then in the box on bottom, storage engine. There were 3 big boxes down there. Access methods,
Transaction manager,
buffer manager,
transaction
transaction manager. All right? Now the key areas of cache. Buffer. We could call the whole thing the buffer. So it's the data and the plan, right? How about the areas inside of that transaction manager? Remember?
log,
Log and log, right? Very good. And all of these are actually something you could follow up with a subsequent session just on the query optimizer, just on the log manager, just on the lock manager, right? What are the 2 processes that conduct the writes out of the data buffer?
daily writer, checkpoint,
Checkpoint is for the data side, and for the plan side,
daily writer.
lazy writer, right? Yeah, very good. Okay, folks, for those of you who don't want to hang out any longer, thanks very much for your time. I hope you'll take a minute and give us some feedback. If you have some more questions, please stick around.